Hi, and welcome to the Implementing and Administering Cisco Solutions, the CCNA 200-301 video series by EC Console. My name is Glenn Singh. In this video, we'll look at getting started with the Cisco IOS. So let's dive on in. What exactly is a Cisco IOS? To put simply, the IOS is the operating system on Cisco routers and switches. All devices require an operating system to operate the hardware and also make decisions, such as how to forward frames, how to forward packets, and so on. The operating system of Cisco routers and switches is known as the Cisco Inter-Network Operating System, or the IOS. The primary user interface for the Cisco IOS is command line. It is not GUI in nature. Just as a computer, a router and a switch has hardware components. There's a CPU, there's RAM. However, it does not have a hard drive. So where exactly does the IOS is stored? It is stored in a very special area in memory known as flash memory. Next, let us take a look at what happens when you power on a router, a Cisco router or a Cisco switch. This here is the boot sequence for the Cisco router or the Cisco switch. The first thing happens is a power on self-test or post. The purpose of running a post is to perform hardware checks on the device to ensure that there's no sort of issues that may prevent the operating system from loading and the device functioning properly. After the power on self-test, it moves on to loading the bootstrap, which checks the flash of the device for the operating system. The purpose of the bootstrap is to locate the operating system in flash and put it in RAM. But what if the operating system is missing from flash? What happens? Well, the bootstrap will check for a network TFTP server. Sometimes network administrators will load the operating system across the network via a TFTP server. In the event a TFTP server is also missing, the bootstrap will load a very scaled-down version of the Cisco IOS, therefore allowing the device administrator to reload or to restore the operating system in the device to make it functional again. Let's assume the bootstrap found the operating system within flash memory and loads it in RAM. Next, the operating system will check if not a special area known as NVRAM, non-volatile RAM, for a file known as a startup config file. Once the startup config file is found, it is loaded into RAM. At this point, any configurations in RAM is known as the running configuration. Please keep in mind that if a startup configuration file or the startup config file is not located, the device will load default configurations on the router or on the switch. Furthermore, the configurations that are done in the running config is not automatically stored in the startup config. If you make any changes on the device, it is stored in the running config. The running config is located in RAM. If the device loses power, the contents of RAM is lost. This here is where NVRAM comes in. So whenever you finish your configurations, tested it, and everything is working fine, you should manually save the configurations to the startup config file. NVRAM, non-volatile RAM, simply means that it will retain the contents even after the device loses power or the device is rebooted. And this here, to put simply, is the boot sequence of the Cisco IOS in a Cisco router or in a Cisco switch. Next, let's take a look at how we access the Cisco IOS. On a Cisco router, switch, or even a firewall, there's a very special port known as a console port. This is a physical management port that provides out-of-band access to a Cisco device. Out-of-band access refers to access via a dedicated management channel that is used for device maintenance purpose only. However, the console port is a primary method to access a device when it is now purchased or it is now unboxed. There's no other way to access and administer a Cisco device without the console port. Another method to access Cisco iOS devices is after you perform device provisioning, you may set up remote access. You can set up Telnet or SSH. Telnet can be used over a network or to provide remote network access into the device to establish a command line session. Please keep in mind that Telnet is not recommended because the Telnet protocol is unsecure by nature. It is highly recommended to use SSH instead. SSH or Secure Shell is a secure method than Telnet, and this is what is recommended. With Secure Shell, the connection between your computer and the Cisco router or the Cisco switch remains encrypted. We talk about the ports. We need to even go a little bit further. How does your computer actually access the Cisco iOS? Well, definitely you will need a terminal emulator program such as PuTTY or Secure CRT. PuTTY is free, you can find it on the internet. Secure CRT is a commercial tool. Additionally, you will need a console cable. A console cable is a special cable that comes with Cisco routers and switches that simply allow you to connect your computer to the actual device via the console port. So let's take a look at what a console cable looks like on Amazon. And this here is a console cable. On one side of the cable has an RJ45 clip, while the other side uses an RS232 interface or a DB9 connector. The newer cables support USB connections from your computer, and the other end here remains as RJ45 that connects to the console port of your Cisco router or your Cisco switch. If you have an older cable such as this one here with the RS232 interface, most likely your computer do not have a DB9 interface. So you can get an RS232 converter cable to USB. And this cable here will bridge the connection between your computer and the console cable, and then the console cable will then connect to the console port of the router or the switch. Now let us take a look at how the console port looks on a Cisco router or on a Cisco switch. Whether it's a router or a switch, the port is clearly defined by the word console, and there's always this blue outline around the interface. Depending on the type of device, the console port may be located at the front of the device or at the back of the device. And this is how you make your initial connection. So let's assume that you have your PC and you made a wired connection. What do you do next? Next, we can head over to our control panel. We can click on Device Manager. And we can scroll down to ports where we see COM and LPT. We can expand it. Right now, I actually have a USB to serial converter cable that is connected. So you can see here, currently this cable is using COM port 3. On your device, it may be different. This is why it is very important that after you connect the cable, you go into your control panel, your device manager, and check to see what COM port are you using. Because now we can take this information and head over to PuTTY. Here we have the PuTTY application. To access the device, we simply click on Serial. We set the speed to be 9600 or 9600. We will then change the COM port value from 1 to 3. Well, in my computer it's 3, but make sure you check your system first. Once this is done, you hit Open. And then your computer will establish a serial connection between your system and the actual Cisco device and access the operating system. So next, let's take a look at the different user modes and then we will do a lab very shortly. These here are some of the main modes that you will be working with within the Cisco IOS. Firstly, when you log into the device, you will be accessing the user exec mode. At the user exec mode, you can perform very basic tasks such as ping and traceroute to test connectivity. You can escalate your privileges and go to privilege mode. At privilege mode is where you will perform all your troubleshooting. You can run a lot of show commands, which we'll take a look at later on, to perform troubleshooting, discover issues, and also to help resolve problems. If you want to make a change on the operating system that may affect the device globally, you can escalate your privileges to global config or global configuration mode. At global configuration mode, any command you execute here will take immediate effect on the device itself. But within global configuration mode, there's additional modes as well, and these are just 3 of the many modes that are available. There's interface mode that will allow you to configure IP addresses and additional configurations on each of the interfaces of a router or on a switch. There's also line mode that will allow you to make configurations and changes to the console port, the auxiliary port, and your VTY lines, which is your virtual terminal lines that are used for remote access. You can even go into router mode that will allow you to make changes and modifications and even set up routing protocols. So let's take a look at what are some of the essential things that should be done during initial device configurations. When initially configuring a device, it should be configured with the most essential things. You should definitely change the default hostname. You should configure an IP address on the interface. If you are configuring a switch, you should configure a switch virtual interface that will allow you to remotely access and administer the switch from a network. You should also set up secure administrative access. You should set a logging banner that presents a disclaimer or a warning to users who are not authorized to access the device. You should create local user accounts, set up secure remote access, encrypt all plaintext passwords, and even disable automatic domain lookups. And most importantly, once everything is working fine, save and backup your configurations. So let's now take a look at actually doing a lab using Cisco Packet Tracer and covering all of these points here. So let us open Cisco Packet Tracer and we'll bring up a router, a switch, and a PC as well. Now let us click on Network Devices, click the router icon, and let us use a 2911 router. For our switches, we can click the switches icon and we'll use 2 2960s. We'll put one here, we'll click on another one and put it here. Don't worry about these names, we will change it accordingly. For the PC, we can click on End Devices, click on PC, and we could put one here, and we'll put another one here. To make the connection between our devices, because we will need some network cables, we can click this lightning bolt. Then we can click this cable, which is this copper straight through cable. And we can click on our PC and click on Fast Ethernet 0, which is our network interface card. We can click on the switch and we'll see a list of available ports. Let us click on Fast Ethernet 0 here as well. For the connection between switch 0 and the router, we'll click back to straight through cable once more. Click the switch, and now let us use Fast Ethernet 0/1. We can drag the cable to the router, and let us select Fast Ethernet 0/1 as well. So now we have established a wired connection between the PC to the switch and to the switch to the router. Let us do the same on the other side as well. But this time we'll be using Fast Ethernet 0/2 between the router and the switch. So now that we set up our physical layout, let us connect PC0 to the router and configure an IP address on Gigabit Ethernet 0/1. So to connect the console cable, on the lightning bolt, we can click this blue cable, which is a console cable. Click it. Now click the PC, and we are going to select the RS232 interface. So we can now drag the cable. Let us click the router, and we'll connect it to the console port on the router. Now, to emulate PuTTY or to access the device, we can simply click on PC0. And now we can click the desktop and click on terminal. These values here are already pre-configured and we don't need to change anything. What we can do next is we can click on OK and scroll down, and now we can see we have access to the actual interface of the router, as in the Cisco IOS. For this question, always type no and press enter 2 times. Don't ever type yes, because the router will make changes in the background without you knowing. So the first thing we need to do is understand what mode we are in. Well, currently, this here, the word router that is highlighted, is the host name. This greater than sign indicates that we are in user mode. Now we can't really do too much in user mode. So let us escalate our privileges and go to privilege mode. We can type enable and press enter. And notice that a prompt changed from the greater than sign to a pound sign. Now we are in privilege mode. But what if we want to go back to user mode? We can type disable and press enter. See? Very simple. And keep in mind that a Cisco IOS keeps a history of the last 15 commands entered. So, by using the up and down buttons on your keyboard, you can recall the history. So let us go back into privilege mode. So now that we are in privilege mode, we can access global configuration mode, where we can actually make changes to the actual router itself. And the first change we want to make is change the hostname. So, to access this mode, we can type configure terminal. And we can hit enter. Notice that the mode has now changed. This here is configuration mode. Configuration mode allows us to make global changes to the device itself. Now to change the hostname, we can use a command hostname followed by the actual name itself, as in what name you want. Now, in the event, if it is we press enter here, the Cisco IOS is telling us that there's an incomplete command. This means that we perhaps forgot something. What we can do to help us figure out what should go next, we can put a question mark. So after hostname, put a space and a question mark. And this here tells us that okay, that there's some sort of word that needs to go after the command hostname. So let us name our router R1 and press enter. And notice here, the hostname changed immediately. Next, let us put an IP address on our Gigabit Ethernet 0/1. But before we do this, how can we determine the number of interfaces available on our router? Well, we can head over back to privilege mode and check the number of interfaces that are available. So, to exit global config, we'll be going back to our previous mode. So we can type exit and press enter. Now we can type show IP interfaces brief. Here we get a list of all the interfaces that are available. We can see whether an IP address is assigned to an interface. We can see the status and method of how the IP address has been assigned. We can see the administrative status, and we can see that each interface is currently administratively down. Status indicates a layer 1 status, and administratively down means to say that there is no electrical service or power on that port, that the interface has been disabled via the operating system. We can see layer 2 protocol, which is also down. So right now we have 3 physical interfaces. There's Gigabit Ethernet 0/1, Gigabit Ethernet 0/0, Gigabit Ethernet 0/2. The interface we want to configure with an IP address is Gigabit Ethernet 0/1. So let's head on over back to global configuration mode. The lovely thing about the Cisco IOS is we don't need to type the entire command. We could type the first part of each command and press enter. So we can type config and ter if you want, and the Cisco IOS will recognize this command as configure terminal, like this. Additionally, we can use tab to help us quickly enter commands. So we can type conf and press tab, and the Cisco IOS will spell out the entire command for us, which is config. We can type ter, tab, and will spell terminal. Now we can press enter. So to access interface Gigabit 0/1, we could type interface. We could type Gigabit Ethernet in one word, or we could press tab and it spells it out for us. Then we just specify the interface itself, which is 0/1. Now, notice that the prompt has changed to config if. Now we are in interface mode. Any command we execute in this mode will affect strictly this interface only. So now let us set an IP address by using the command IP address. Next with an IP, so we can give it 192.168.1.1. Space, and we have to give it a subnet mask. So let's use 255.255.255.0. And press enter. Additionally, we can set a description under this interface to help us understand what is the purpose or what is associated with this interface. So let's use a description command and set a description of our own. Since the interface is administratively down, we can turn up the interface by typing no shutdown and enter. As you can see, we got a system message indicating the interface has changed. If we head over back to our privilege mode, we can verify whether the interface has truly came up or not, without even taking a look at the topology. So, since we are in interface mode, we can type exit, then we'll head back over to global config. We could type exit again, which will then carry us back to privilege mode. But a quick shortcut is we can press Ctrl and Z, and this will carry us back straight to privilege mode. Let us check our commands. Let us check our interface using show IP interface brief. Hit enter and take a look at this. We now have an IP address that's manually set and the status is up. Excellent. Now, what we can do is we can put an IP address on our PC 0 and test to see if there's network connectivity. So let us close the terminal, click on IP configurations, and let us statically set an IP address on our computer. We will also set our gateway, and our default gateway is router 1. So we'll set the IP address that is associated to gigabit Ethernet 0/1. Now the IP address has been set, let us close this window and head over to the command prompt of our PC0. Here, we will use the command prompt to test connectivity between our PC0 and router 1. And we have successful responses. We are sending 4 ICMP ping packets and we are getting back 4. There's 0% loss. So this means the PC has connectivity to the router. Let us head back to our terminal. Let us go back to user exec. And the cool thing is that we can perform connectivity tests right from our Cisco IOS. We type ping followed by the destination IP. So right now we are on the router. Let us ping from the router to PC0. And we have successful responses. The exclamation mark simply means success. If we see a dot only, the dot means request timeout. And if you get a U will simply mean that the destination is unreachable. But we'll take a look at the different results that we get from using ping and even traceroute in later sessions. For now, we want to ensure we have end-to-end connectivity. Let us configure another IP address on gigabit Ethernet 0/2. Now that we are in the interface mode for gigabit Ethernet 0/2, we need to put this interface on a totally different network. So let us use a 172.16.1.1 network. Let us set a subnet mask as well. And let us set it a description. We must turn on our interface. And now the interface should be on. But being a good network engineer, we need to verify this. So let us head back to privilege mode and run our show IP interface brief. And we can see here the IP address has been assigned manually and the interface is in an up status. What we can do next is attempt to ping PC1, which is located on the right side of the router. So let's assume that PC1 has an IP address of 172.16.1.10. Let's see what happens if we try to ping from the router. So remember, we have not assigned this IP as yet to the actual PC1. And clearly we can see we are getting dots. Each of these dots simply mean it's a request timeout. It means to say the ping is going, but we are not getting a response. So now let us put the same IP address on PC1. So click on PC1. Click on desktop, IP configurations, and now let us set the IP, subnet mask, and default gateway. Alright, so now that we have set the IP address on PC1, let us head over and log in back to the router and perform a ping test from the router to PC1. And notice here, the first ping dropped, but the other 4 were successful. This simply means the time it took the router to send an ARP, an address resolution protocol, to resolve the IP address to MAC address, it took a little too long. But by the second ping message to go across, we got successful response onwards. If we perform a ping test once more, we'll get all success. And there we go. The router is now able to ping the PC. Well, PC1 that is. Next, let us take a look at securing administrative access onto a router. So, I'm pretty sure you have noticed that you can move from user mode to privilege mode to global configuration mode very easily. And this means anyone who has access can do the same and make changes to your device as long as they understand the Cisco iOS. How about we set a password that will prevent someone from moving or escalating between user mode to privilege mode? Well, this can add some layer of security. To do this, we can use the enable password command in the global configuration mode, like so. The command is enable password, and let us set the password to be Cisco123. And press enter. Now the command has been accepted. Let us go back to user mode and try to access privilege mode and see what happens. So now I'm at user mode. Let me type enable. And look, it's asking for a password. Keep in mind that whenever you type a password in the Cisco iOS, it is invisible for security purposes. The downside of using the enable password is that it stores a password in plain text. So now that we are here in privilege mode, let us run another show command. Remember, all the show commands are executed in privilege mode. So let us take a look at the running config file or the running configurations. To do this, we could type show running-config. Or you could type show run, press tab, it spells it out for you, and press enter. Looking closely, we can see the configuration we made with the host name. We can also see the configuration that we use to actually set the password, and the password is in plain text. The downside of using the enable password is if someone has access to your privilege mode, the person can simply check the running configuration content and get any sort of password stored. In case you're wondering how to see the rest of the configuration, you can press the enter button and this will give you line by line. If you press the space bar, it will give you pages. So here we can see where we set the IP address and we set the description command. However, if you don't want to see the additional content within the running config, you can press Ctrl and Z to quit it. Now, let us set a much more secure method of accessing the privilege mode. This time, let us head back over to the global configuration mode and use the enable secret command instead, like so. This time, let us set the password to be Cisco456. Press enter. Next, let us check to see whether this password is secure than the previous or not. So we can go back to privilege mode by pressing Ctrl Z, or we can type exit. Then we can take a look at our show running configuration file. And notice here that the enable secret, the password is now a cryptographic hash. So now the password is actually encrypted. The bigger question now is which of these passwords will work for you to access privilege mode if you are in user mode. To put simply, the stronger password will always take precedence. Even though both of these exist, the stronger one will take precedence. So, the enable secret password will be the only password that works for you to access the user mode to the privilege mode, providing that you have an enable password and the enable secret set. It is good practice to actually remove the enable password if you already have an enable secret. And to remove a command or to remove a setting, you must go into the mode where the command was executed and use a negated form of the command. So let's take a look at how to remove the enable password. We need to go back to global config. And we can type no enable password and press enter. And this will remove the enable password set from the running config. But we need to verify this. So let us go back into privilege mode and take a look at the running config once more. And here we can see it was removed completely. Next, let us take a look at setting a logging banner. The logging banner is used as a disclaimer that simply tells an unauthorized user that if he or she should access a device, they can be prosecuted by a court of law. So to set a login banner, we must go into global config. We can use the command banner motd and to set a text message here, we need to use special characters that would function as quotation marks. And everything within these special characters will be printed whenever someone logs in to the device. So special characters can be the %, followed by the message. So you can say keep out. And we must use the same delimiter, which is special character, to close. And press enter. So this means if someone connects to the device for the first time, they will get that logging banner. So let's test this out. I'm going to press enter one more time. And here you can see the logging banner is now presented as keep out. Remember the password is Cisco 456. So now we have a logging banner set. Furthermore, have you noticed that we can simply connect a console cable to the console port and access the device? Well, we can secure that console port by setting a password as well. So let's do this. We need to go into global config. Next, we need to go into the console port. The console port is considered to be a line. So you can type line, console, and 0. 0 being the first number. And now we are able to access the console port and make changes. Here we can set a password. So let us use a password command. And let's set a password as Cisco. Press enter. Now the password is set. But authentication is not enabled. To enable authentication, we can type in logging. Logging will always prompt the user to provide the console password. Remember, the console password is Cisco. So we can press enter. And now, let us logically disconnect ourselves and reconnect via the console interface. I'm going to press enter one more time. I should get the banner. And I also should be prompted to enter the console password. Let's see what happens. And there we go. We have the banner, and this password is a console password, which is, in this case, Cisco. Type enable, or EN for short. Now it is asking for the privilege mode password, which is Cisco 456. Let us take a look at our show running config once more. Let us head down to the actual console lines. Press spacebar a couple of times. And here we can see the password is set, but the password is unencrypted. What we can do is, rather than we set the password on our console line, we can create a user account on the actual router, and anyone who wants to log in via the console port, or let's say remote access, that they should be prompted to enter a user account instead, which is much more secure than simply leaving this password as it is. So let's now create a user account, and then we will go and configure the console port to use or query the local user account that is. So let's jump in. We can use the command user or username. We can use the command username followed by the user name itself. So you could say admin as the user, and we can type password. But if we use the password command, the password itself will be unencrypted. It will be unsecure. However, we can use secret. And just for simplicity, let's set the password to be class. Press enter. So now we have created our first user account on the Cisco iOS. Let us configure our line console 0 interface, or the console port, to actually use this password and username that is created here. So you need to go back into line console 0. And good practice, let us remove the password that we set there first. So you can type no password, and this will remove the password Cisco. Now that we remove the password Cisco, let us tell the console line, hey, use the local user account. We can do this by using the command logging local. Logging will enable authentication, and local will simply use this account that we have created. I'm going to hit enter, and now let us test our authentication for our console line. So I will exit and logically disconnect the cable and reconnect again. In case you get this translating message, it simply means that you enter a possible host name that the device will try to perform a DNS lookup. This translation takes a while before it stops, and in case you want to disable it, you could type, in case you want to disable it quickly or abort a command or abort some sort of process like this, simply use Ctrl Shift and 6, the number 6 that is on top of your keyboard. So now I am now making a new connection. I'm going to hit enter. I got the banner, and now it's asking for the username. Let's use admin. The password is class. Admin and class. And there we go. We got back access into the user exec mode of the router. Let us head back to global config and actually disable the automatic domain lookup. We can type no IP domain. We can put a question mark in case we're not sure what the command is, which is good practice as well. And you can see it is -lookup. And press enter. And this will stop the translating message that you may ever see ever so often. Another command that is very useful is we can encrypt all plaintext password, because some of the commands does not allow us to set a secret password, but they allow us to set a regular plaintext password. It is good practice to use this command to encrypt all plaintext password that is existing and all future plaintext passwords automatically. The command is service password encryption. Like so, hit enter, and now it's enabled. At this point, we have did some basic initial configurations on our router. What we can do now is actually save our running config into our startup configuration file. simply that if this router reboots or loses power, we will lose all the configurations. To save our configuration, we need to go to privilege mode and type the command copy running config space startup config, like so. So we have copy running config startup config. Press enter. It will ask you the destination file name. This value is already set by default. We can press enter one more time and it will build the configuration for us. To test to see if our configuration is saved properly, we can type show startup config to view the details of our startup configuration file. But we can simply reload the router from here or reboot the router. The command is reload. Type reload, press enter. It will ask you if you want to confirm. Press enter to confirm one more time and we will see it has rebooted. The Cisco IOS has been decompressing from flash and is being loaded into RAM. Next, the router will check for the startup config and load the contents into RAM. I'm going to press enter one more time, and if the startup config works exactly as expected, we should get a banner that is also prompting us for a username to access the console port. And there we go. We have the banner, which is keep out. It is asking us to verify our credentials, which is admin, password is class, and we have access back into the router. You can save this lab on your desktop so you can use it at a later date, or perhaps you could practice some more. So ensure that you save your router configurations, click File, Save, and save the file. In this video, we took a look at understanding the need for the Cisco IOS, which is simply that an operating system will control the hardware for us. We look at exploring the boot process, and you got some hands-on on configuring the Cisco device. Don't worry too much if this particular domain 1, don't have too many practicals. In domain 1, it's literally the network fundamentals. It's a foundation for you to understand all the networking aspect, terminologies, and how things work. By domain 2 and onwards, it is a lot of practical. So for now, we'll take it very slowly through domain 1. In the next video, we'll take a look at comparing physical interfaces and cabling types. I hope this video has been informative for you, and I hope to see you in the next one.